And we're going to start off by looking at a question from a student. This is actually from today's lesson, but that's okay because the material still pertains to what's going on. It says graph the equation y minus 2x equals negative 9/8. Okay, so the equation is y minus 2x equals negative 9/8. What I want to do, I don't know if you can see over here on the web assigned the ordered pairs that the student chose, but I'm going to use the same x values, which was x was 0 and x was 4, and see what we come up with. I think their calculations are off, but we'll see. All right, so we're going to find two ordered pairs. First of all, if x is 0, and we put that into this equation, we get y minus 2 times 0 equals negative 9/8, which would be y minus 0 equals negative 9/8, or just y equals negative 9/8. So the first ordered pair should be 0, negative 9/8. Next, we're going to let x equal 4. If x is 4, y minus 2 times 4 equals negative 9/8. Y minus 8 equals negative 9/8. Add 8 to both sides, y equals negative 9/8 plus 8. Well, now we're trying to add a fraction and a whole number. Let's take that whole number and turn it into a fraction just by writing it over 1. The common denominator now would be 8. So I need to take 8 over 1 and get it as something over 8. But if I multiply the denominator by 8, I must also multiply the numerator by 8, which gives us 64/8. Negative 9 plus 64 would be what? 55/8. So there's the two ordered pairs that we should use. And if you look here, they've got 0, negative 1 and 4, 7. Now, this is almost negative 1. And this is almost 7, but almost doesn't cut it. So the calculations were slightly off. That's why the problem was marked incorrect. Okay. Any questions about that before we go on? Alrighty. Let's see here.
No.
Yeah. I want to change what I'm doing over here in WebAssign. So give me a minute. Back to it in a little bit. All right. So I still want to just use the whiteboard screen. A couple of things we're going to look at today. One of them is called intercepts. And to do that, let's go back here to a graph. Suppose I have the following line. Let me draw it here. Give me a second. Can you see that this line that I've drawn cuts through the x-axis and the y-axis? You see how it intersects those axes, so to speak? The coordinates of the point where it intersects with the x-axis is negative 4, 0. The coordinates where it intersects the y-axis is 0, 2. Any questions about that? All right, let's take a look at another example. Okay. Here we have a graph. that intersects the x-axis at what, 6, 0, and it intersects the y-axis at 0, 4. Any questions about that? Here we have a graph that intersects the x-axis and the y-axis at the same time at the origin. And so the point of intersection is 0, 0. Now, on all of these graphs, the points where the lines cut through the graph are called intercepts. So for this problem, this point is the x-intercept. This point is the y-intercept. Notice where the graph cuts through the x-axis, y is 0. When the graph cuts through the y-axis, that is the y-intercept, the x value is 0. So we could generalize and we could make the following statement. We could say to find an x-intercept, set y equal to 0, or I'm going to say complete the following ordered pair. Okay, so to find an x-intercept, set y equal to 0, or complete the following ordered pair. In other words, put y in for, or 0 in for y, solve for x. That will be the point where it cuts through or intersects the x-axis. To find a y-intercept, set x equal to 0, or complete the following ordered pair. Oops. Okay, so to find an x-intercept, set y equal to 0. To find a y-intercept, set x equal to 0. Any questions about that? Okay. I want to use an example, but I'll need volunteers from our studio audience. So if you're willing to talk, we'll do it. If you're not, that's fine. We'll do something else. But are you willing to participate?
Yes.
Okay. So, and you can make stuff up if you want, but think in terms of what would be reasonable. So my question, first of all, is, do any of you buy lattes at a latte stand?
Yes.
Yes. Okay. So how many a week would you say?
I'm more like maybe 2 a month.
Oh, 2 a month. Okay. So you're not a big latte drinker. Any
No.
of the rest of you, any big latte drinkers there?
Yeah, maybe 3 or 4 times a week.
Okay. Okay. All right. So we're going to pick on you. Okay. So you said 3 or 4 times a week. What do you pay for those?
$5.50.
$5.50. Okay. So in fact, let's do this. Let's just, so you 3 times per week and you pay $5.50 per. Okay. What if the price went up to, let's say, $6? Would you still buy 3 a week?
Yeah, I think I would.
Okay. What if it was $7? Would you still buy 3 a week?
No, that's a little too much.
What's that?
No, I don't think I would buy them.
Would you buy maybe 2?
Maybe.
Okay, so we'll say 2 times per week, $7. Okay. What if they were $8? Would you still buy 2 a week?
Let's go down to 1.
You go down to 1. Okay. So one time per week, $8. Okay. What if they were $10 a piece?
No,
You wouldn't buy any?
no.
Okay. All right, let's go the other direction. What if they were cheaper? What if they were like $3? Would you get more than 3 a week?
5.
Oh, okay. So 5 times a week at $3. What if they were $2? Would you maybe get 2 a day?
Oh, yeah, I can do that. Okay, 2 a day.
Would you though? Do you think you would if they were just $2?
Yeah, I think I would.
Okay, so you'd buy like 10 of them?
A week, right? Yeah.
Yeah. Okay. What if they were free? How many do you think you'd consume in a week if they were free?
Let's say 12.
12. Okay. So 12 times a week if they were free. Okay, now, this isn't a perfect model, but I want to use this information to represent something here. Let's see here. So we're going to go $5, $10, and let's see here. We'll go 12. So this is price, and this is times per week. Okay. Now, my model, I'm kind of fudging a little bit because the information that you gave me doesn't exactly fit a straight line. But the point I want to make is this. This graph, this axis represents the price that you would pay for a latte, okay? So I've got it marked off at $5 and $10. This axis represents the number of times per week that you would get a latte. So what's the price right here? It's 0, right? So when the price is 0, you said you'd get 12 lattes a week. Okay.
Yes.
When the price was $10, you said you wouldn't buy any anymore. So what I want to look at here is this graph. Do you see that as the price increases, the number of times per week that you're willing to purchase a latte goes down? Does that make sense? The more it costs, the less you buy, the less it costs, the more you're willing to buy.
Like a slope.
Bingo, like a slope. But what I want to look at, my point of this whole example is that these 2 points are significant points on the graph. They are the X and Y intercepts. This shows the price at which you no longer will purchase any. So the price has outdone the desire to buy it. This shows how many you would consume if it was free. But those are X and Y intercepts on a graph. And the whole point of this example is just to show that in the real world, when representing something graphically, those intercepts are often important points to do with the situation, okay? And that's one of the reasons that we're going to be making a big deal today out of intercepts, okay? Now, what I want to do is, this is some examples from the book. This says, find the X and Y intercepts of the graph of each equation, but do not graph the line. So we have an equation, 8x plus 3y equals 24. So to find the X and Y intercepts, basically, I'm going to complete this table. to find the x-intercept, set y equal to 0. So we'll say that's the x-intercept. To find the y-intercept, set x equal to 0. Okay? So if y is 0, I get 8x plus 3 times 0 equals 24. 8x plus, well, 3 times 0 is 0 equals 24. 8x plus 0 is still 8x. So 8x equals 24. Divide both sides by 8 and x equals 3. So the x-intercept of the graph of this linear equation is at 3, 0. Okay. To find the y-intercept, set x equal to 0. 8 times 0 plus 3y equals 24. 8 times 0 is 0. 0 plus 3y is 3y. So 3y equals 24. Divide by 3 and y equals 8. So there are the two intercepts, the x and y intercept. Now it said not to graph it, but I'm just going to do a rough sketch here. So let's see, x is 1, 2, 3, y is, we'll say 8. Okay, so that's what I get for trying to do it freehand. Anyway, my point is you've got an x-intercept at 3, 0 and a y-intercept at 0, 8. Okay with that? Any questions there?
No.
All right, let's take another look. I'll look at another example. 2x minus 9y equals 36. So once again, to find the x and y intercepts, we'll set y equal to 0 and then x equal to 0. Set y equal to 0 to find the x-intercept. Set x equal to 0 to find the y-intercept. If y is 0, 2x minus 9 times 0 equals 36. 2x minus 0 equals 36. 2x equals 36. X equals 18. Okay. If x is 0, 2 times 0 minus 9y equals 36. 0 minus 9y equals 36. Negative 9y equals 36. Divide both sides by negative 9. Y equals negative 4. So again, at what, 18 and at, let's see, negative 4 in terms of x and y, okay, you'd get this graph, okay, and the scale's off and everything. I'm just, again, trying to kind of give you a rough idea of how that works. All right, are you okay with that idea?
Yes.
Okay, so now let's take a look at some WebAssign problems. This one says, consider the following graph. We already have the graph. What is the x-intercept of the graph? Well, where does the graph cut through the x-axis? Right there. So what are the coordinates of that point? It would be negative 2, space 0. Any questions there? All right. To find the y-intercept, where does it cut through the y-axis? When x is 0 and y is
Negative
1. Good. Now, this is one of those things where I've told students quarter after quarter till I'm blue in the face, and still a number of students don't do this correctly on a test. They'll just do this. Okay, let's see what it says. Oh, wait, for the y-intercept, they'll put in negative 1. So they'll just give me the non-zero value. Let's see if that's acceptable. No, it's not. It's an ordered pair. For an x-intercept, you've got to put in y is 0. For a y-intercept, you've got to put in that x is 0. Okay, There are some situations where it's acceptable to leave out the 0, but WebAssign is not one of them. So to get it correct, you've got to put in an ordered pair. Any questions about that? Okay.
No.
Let's see here. These are just doing basically the same thing. Let's take a look at this problem. It says use the intercept method to graph the equation. So we've got the equation 6x plus 5y equals 30. I'm going to complete a table by finding the x-intercept and the y-intercept. Setting y equal to 0, 6x plus 5 times 0 equals 30. 6x plus 0 equals 30. 6x equals 30. Divide by 6, x equals 5. Okay. If x is 0, 6 times 0 plus 5y equals 30. 6 times 0 is 0. So 0 plus y, 5y is 30. 0 plus 5y is just 5y. So 5y is 30. Divide both sides by 5. Y is 6. So now I have my two intercepts. Now, my goal here is not to plot points. It's to graph this linear equation. So to graph the line. So I want to graph a line. Okay, not just points, but rather a line. Okay, so my scale, 1 square is 1 unit, 5, 0 is right there. 0, 6 is right there. Let's go here and check the ordered pairs. 5, 0, 0, 6, that's correct. Okay, so that should be the correct answer. I'll submit the answer and see what it says. All righty. Any questions about what I just did there? Okay. Do you need another example of what I just did? All right. Then we'll go and look at the second part of this lesson. Let's see here. We're going to move that. Let's say I have the following equation. X equals 4. Okay. There's only one variable in that equation. Suppose I wanted to complete a table and find some ordered pairs. Well, let's see. Oh, let's find the x-intercept. So we'll set y equal to 0. Well, if y equals 0, what is x?
Four.
Yes. Oh, let's pick another value of y. How about 2? If y is 2, what is x?
4.
Oh, how about if y is -3? What's x?
4.
Not to insult you, but way to go, Captain Obvious, right? What is x? What is x? It's 4. No matter what, y isn't even in the equation. So it doesn't affect x. So y could be anything it wanted to be, and x would be 4. Okay. So what's that going to look like as a graph? All right, I'm not going to use the x plus 3y equals -6. I just want to use this grid though to show. All right, what are we doing here? Here we go. Where did it go? There it is. Sorry. Okay, let's plot some points there. If x is 4 and y is 0, we've got that point. If x is 4 and y is 2, we've got that point. If X is 4 and Y is -3, we've got that point. Oh, it doesn't, it only wants 2 points, but what does that line look like? How would you describe that line? And I know it's a straight line, but is it
The
going?
vertical line, isn't it?
Exactly, it's a vertical line. X equals 4 is, or I should say, the graph of X equals 4 is a vertical line. Because if X equals a constant, Y can be anything it wants to be, but X is always going to be that constant. And if you have a line with the same X value all the way up and down it, it's going to be a vertical line. Okay with that? How about this? X equals -3. What would that look like? Now let's clear that. Again, I'm not using that. I'm just using the grid to put stuff on. What would that look like? X equals -3. That would be a vertical line passing through -3. Because no matter what Y is, X is -3. We okay with this? Any questions there?
No.
All right. Let's talk about Y equals a constant. How about Y equals 8? Well, oh, if X is 0, what's Y?
8,
If X is 1, what's Y?
8,
If X is the square root of pi, what's Y?
8.
Yeah, I wouldn't want to have to find that. But the point is, for every X value, Y equals 8. So what is that going to look like? Well, let's see. If X is 0, Y is 8. If X is 1, Y is 8. Who knows or cares at this point what the square root of pi is? What are we getting there? What kind of line is that?
A horizontal line.
Yep, the graph of Y equals 8 is a horizontal line. So X equals, I'm going to say a constant, meaning just a number, vertical line. And Y equals a constant, horizontal line. In fact, yeah, maybe I should do this. Vertical line, horizontal line. Okay. Two other things we've looked at. To find an x-intercept, set y equal to 0. To find a y-intercept, set x equal to 0. So there's 4 pieces of information that you want to have memorized right up here. Okay. Now, let's see here. Look at this web assignment problem. Graph the equation y equals 6. So is that going to be horizontal or vertical?
Vertical.
Mm,
Sorry, I mean horizontal.
yeah. Look over there. Okay. So y equals 6. Or another way of looking at it, which of these graphs is every point on the graph have a y value of 6? Well, here y is -6. Here y is all kinds of values. Oh, here it is. Horizontal line. Okay. That looks like a decimal point, but it's supposed to be a comma. Anyway. Yes, it's correct. So y equals 6. Tell you what would be the equation? Let's do this. What would be the equation that would describe this line?
An equation or the ordered number?
The equation.
I don't know.
It would be y equals -6. Y equals -6. That would be a horizontal line, and all the y values would be -6. Are you seeing that?
Yes,
What's the equation of this line?
well, y would be multiple numbers if it was y.
Okay, so what is it? It's a vertical line. What's the equation of a vertical line?
X equals 6.
Bingo. We already know this one. How about this one? What's the equation of this line?
X equals -6.
Good job. This one doesn't fit either of those categories. All right, here it says graph the equation x equals 2. Horizontal or vertical line?
It's a vertical line.
So x equals 2. Let's see. There it is, right? See it?
Yes.
Okay. Let's see here if there's anything else I want to do. I think that's it. Oh, look at the scale here. Let's do this one. It's got a huge scale on it. It's like an octopus with a huge scale. What is, octopi, do they have scales? I don't know. Anyway, I digress. All right, graph the equation. Let's use the intercept method, okay? Now, some of these, it says, let me go back here a ways for a minute. It'll say use the intercept method to graph the equation. In those cases, what you're going to do, and again, this was wrong, right? Because I was just using that graph to graph other stuff. When it says use the intercept method, that's where you're going to make a table and use the x and y intercepts, okay? Now, when it doesn't say use the intercept method, back to where it was here, you still could use the intercept method, but you could also pick other values of x or y to fill in your table, okay? I'm going to go ahead and use the intercept method on this one, even though it doesn't specify that. X equals 90 minus 9y. If y is 0, x equals 90 minus 9 times 0, x equals 90 minus 0, x equals 90. If x is 0, 0 equals 90 minus 9y. I'm going to add 9y to both sides of the equation. 9y equals 90, divide by 9, y equals 10. So 90, 10. Oh, excuse me, 90, 0. X is 90, y is 0, and 0, 10. And I'm going to go here to make sure 90, 0, 0, 10. And there we have it. All righty. Any questions? Oh, let's take a look at this one. It says graph the equation -4x equals 10. That's not in that form of x equals a constant or y equals a constant yet. But it does just have one variable. So what if we solve for that one variable? We get x equals -5/2. So that would be a vertical line passing through -2.5, which is this one right here. Okay with that? So again, if it only has one variable, but it's not in the form of x equals a constant or y equals a constant, solve it so it is in that form, and then that'll tell you where to draw your line. So sooner or later, you got to know where to draw the line, right? Okay. Anyway, that's all I have for you today. I will be back at 1:15 with an office hour, should you have need of me. Otherwise, have a great rest of the day. I will stop the recording.